Alright, so in this video I'm going to go over homework or programming assignment number 8. So I'll start here with the server class. You'll notice that this server class is made abstract because we're not going to be able to actually instantiate one of these. We've got the name, the operating system, the hard drive capacity, and then we have the static variable to keep track of the number of these server objects that we've got. And here, basically, all I have is I just have an empty argument constructor that increments num servers. In other words, I'm going to be using the constructors of file server and web server, so I didn't really need one here. My getters are all pretty much standard getters. My setters, fairly standard. I do some basic error checking for, nulls and things. Notice for the setter for my OS, I check to make sure that it's Windows, Linux, or OS X. Hard drive capacity, I check to make sure that it's greater than 0. Then I have this abstract method for computing the usage. So depending on the type of server, whether it's a file server or a web server, the way that I compute the usage is a little bit different. So I go ahead and make this abstract, knowing that I'm going to have to provide an implementation by overriding this in the subclasses. And then I have a toString, which just prints out the parameters or the attributes inside here. Notice that I use the getClass.getName to print out the type that it is. So that, in other words, this will print out whether it's a file server or a web server. So because of dynamic binding, depending on the actual type of server that I end up using, this will return the correct method, and it won't just return server. It'll return file server or web server. So that's why I decided to do that. And then I have my equals method here, which just takes the incoming object O, checks to make sure that it's a server type. If so, it does the downcast. And then it basically is comparing the names. So as long as the server names are the same, it's saying that the servers are the same object. So I guess it ignores all of the other attributes like operating system and hard drive capacity, which is fine. I don't know that we even end up using this. So anyway, so that's the abstract server class. Okay, file server. You'll see that it extends server. All right, we have one instance variable, the number of users. Now, you might think, oh, well, I should probably put the usage as an instance variable. And I decided not to because usage is something that can be computed and it's based solely on the number of users. So there's no reason to store a separate variable if I can just easily compute that every time. Because then I don't have to keep the usage in sync with the number of users, right? All I have to do is get and set the number of users, and then at any time I want the usage, I can just compute it. So now I suppose if compute usage was a much more time and memory intensive operation, then I might want to store it for performance reasons, but in this case I don't need to do that. So, so there's my getter, there's my setter, pretty standard stuff there. This max users is just a constant for showing that you can only have up to 5,000 users. So this compute usage was overridden. So this was originally defined as an abstract method in server. And so here's my function for overriding it. We just do 0.05 times the number of users. And then this is the cap to make sure that if it's greater than 100, we just cap it at 100. Okay, then we have a toString, which just basically calls the toString in the server superclass and then adds on the number of users to the tail end of that. And then we have, again, an equals method, which all it does is it checks to make sure that the incoming object is an instance of file server. If so, it does the downcast and then compares the names. So I guess here we're just saying that the file servers are the same if their server names are the same. Okay, we probably didn't even need to do this. We probably could have just made a call to super equals, and that probably would have been adequate, but I don't think we end up using this anyway. So then in web server, so web server has this software array of strings. The WS multiplier is for computing the usage. So we have a getter, which calls this make copy function. And the reason why we have to make a copy is because software is an array. So remember, when we have arrays as instance variables, we have to make copies whenever we do gets or sets. So I just created this handy make copy function, which accepts an array of strings and returns an array of strings. And basically all it does is it creates a brand new array of strings, copies all of the information from the incoming array into the new array, and then returns the new array. So that's what make copy does, and we use it here in both the getter and we use it in the setter. And the reason why, again, we have to do that is because if we didn't make a copy and we just returned software, then we could potentially be violating information hiding. Okay, so then we have our compute usage. So the compute usage here is simple. It's just that multiplier, the 20 times the number of items in the software array. We know that the software array has to be between 2 and 4 items. We probably could have done, I guess here in the setter we do that check. We check to make sure that it's between 2 and 4. Otherwise we throw an exception. And then the toString method, so we call the superclass, and then we add on this software label, and then we loop through each item in the software array, add that to the list of software, and then we return that string. So you'll notice here I'm looping from 0 to software.length -1, and that's just so that I don't have a trailing comma at the end. Okay. And then the equals method, again, pretty standard equals method. We're checking to make sure the incoming object is an instance of web server. If it is, we do the downcast, and then we compare the names. Okay, so again, I don't think we end up using that anywhere. All right, so now on to the implementation class, where there's a lot of the work happens. I'm not going to go over all of this. So all this stuff here in main is the same as in previous assignments. This main menu is exactly the same as in previous assignments, so I'm not going to spend a whole lot of time talking about that. All right, so here's where we create a server. Again, the first part is the same as in other assignments. We're going to check to make sure that we haven't exceeded the number of servers. So that's what this part does. And now let's move on to where the work happens. Okay, so first we're going to have a reference to a server object. Now remember, server is abstract, so I can't actually instantiate server. Okay, but we're just going to initially set it to null so that we have this new server reference here in case we need it later, which we will. So we're going to do our standard loop construct to get the name of the server. So that's what all this code is right here. Okay, then we are going to ask the user what type of, whether they want a file server or a web server. So this code right here, I basically got right out of the JOptionPane API documentation. It shows you how you can basically present the user a choice of what they want. And so that's what I've done right here with this code. And so if they select file server, then I'm going to create a new file server. Otherwise, I'm going to create a new web server. And so I'm taking that file server, that web server, and I'm putting it, and I'm referring to it with that new server server reference that I've got. Okay. And then I call the setter for the name. All right. You'll notice that I'm just using empty argument constructors here, and that's because I just basically decided I'll go ahead and create a generic object, and then I'll just call the setters as I go and collect each piece of information. Okay, and in fact, you'll notice I didn't actually even put a constructor in here. You probably were supposed to do that, so I probably should just put in an empty argument constructor that doesn't do anything, because that's effectively what I've got here for both file server and web server. There's no constructor, so it's going to fall back to using the superclasses constructor, which is this one. Okay, so at any rate, so then I call the setter to set the name. Then I have my loop construct for getting the operating system. Oops, went a little too far there. All right, let me see. Okay, so there's the name. So there's the operating system. All right. There's the hard drive capacity right here. All right. So then we check to see if it's a file server, then we're going to get the number of users. Okay. And you'll notice that I'm actually doing my setters right here. See where I'm doing new server.set HD capacity and new server.set OS. Okay, I'm doing it right here inside this construct. So, all right. And, okay, so then we say, all right, if we've got a file server, then we need to collect the number of users. Okay. So first I'm going to downcast that new server to a file server. That way I can call the setNumUsers method, okay, which is only a file server method. That doesn't pertain to web servers or just abstract servers. Okay, so by doing this downcast, it allows me to call the setNumUsers, and then I have the same construct. Okay, over here for the web server, okay, we're going to ask them how many pieces of software there are so that we know how many times to prompt them. So we know that there can be as few as 2 or as many as 4. So this right here asks for a number between 2 and 4. Okay, once they've done that, we initialize this new array that we're going to use to store the names of all those software pieces. And then we loop through that array. And again, we have the same kind of done looping construct to prompt the user to put in a web server software package name. And we stick that into the appropriate place in this WS software array. Okay, once we're out of all of that, we go ahead and we downcast web server, or we downcast the new server reference to a web server so that we can call the set software method and pass in this WS software array that we created into that setter. Okay, now that we've done all of that, we can make sure that we take in that reference, new server, and stick it into the right spot in the giant array of servers. Okay, so that's basically create server. It's, again, not too dissimilar from other assignments. The wrinkle being that we have to do this instance of kind of stuff to figure out if we've got a file server, then we kind of do one set of actions. And if we have a web server, then we have to go gather some additional, different information. Okay, so... All right, so the valid name. So one of the things that I guess I skipped over is up in here at the very, very beginning of create server. Where is it? All right, at the very beginning of create server, when we get the username, one of the first things that we do is we call this valid name function, okay? Because we had a requirement that you cannot have 2 servers with the same name. Okay, well, that's a little bit awkward because we have this servers array, all right? So basically what we need to do is every time we try to create a new server, we have to look through this array and make sure we don't already have a server in there with that name, all right? Because what you wouldn't want to do is you wouldn't want to go ahead and create a whole new server object only to, at the end, find out that, oh, well, there's one that's the same name, because then you'd have to go delete it out of the array. That would be kind of annoying. So we do the check right here up front. Okay, so I have this valid name function, and it accepts the string of the server name you want to look to see if it's already in there, and then the whole array of server objects. Okay, so scroll back down to where that is. All right, so you see that test is the server name you're checking, and then servers is the array of servers. So what we're doing is we're looping through all of the servers that we've got, and we're basically saying if the string test is equal to the server name, servers i.getName, then we're going to say nope, it's not valid. And if we get through that entire loop without it finding it, then we'll say okay, that is a valid name because it's unique. All right, so that's that validation function. All right, there were a lot of different ways you could do this, but this is probably the easiest and cleanest. Okay, so then we have the display all method. So this is going to basically just print out a list of all of the servers. So we check to make sure that there's servers to print out, and then we have this results string, and we are going to loop through all of the servers, and we are going to total up the hard drive size, and we're going to append the string output of each server. So it'll, depending on whether it's a file server or a web server, it'll print out slightly different stuff. Add that to this results string. And then at the end, we'll add on the total number of servers, the total hard drive capacity, and pop that up in a dialog box. Okay, and then so for average user, again, it's a little bit awkward because we have both file servers and web servers in this array. What we have to do is we've got all these variables here. We have variables to keep track of the file server usage and the count of file servers, as well as the web server usage and the web server count. You probably could have used static variables inside the file server and web server to keep track of the number of those particular types of objects if you had wanted to, and then you wouldn't have to do this count. But you would still need to do this usage kind of scenario. So basically what we do is we loop through the array, and we have to check to see if it's a web server, then we're going to add the usage to the WS usage variable. If it's a file server, we're going to add that usage to the FS usage variable, and we're going to increase these counts to sort of count the number of web servers and file servers that there are. And then right here, we're basically computing the average. So that's what these things are doing here. The sum divided by the number that there are. And that gives us the average file server usage and the average web server usage. So we just go ahead and stick that into a string and pop it up in a window. Okay. And then we have the highest usage. So again, similar kind of a situation as the above, in that we're looping through all of our servers. For the web servers, we are checking the usage because we want to get the highest usage web server only and the highest usage file server only. So we're basically going through and we're checking to see whether or not the current iteration through the loop is higher than the highest one previously seen. And so that's what all this code does. And when we're done with that, we just print it out. Okay, so this is a very similar kind of a method to the last one. Okay, so this get numbered list of servers is just a helper method for when I print out. Actually, I'm not even sure if I end up using this anywhere. Maybe I use it in my. Let's see, it's get numbered list of servers. If I go back here to display all, nope, I don't even bother displaying it in display all. So that's just, I think I probably copied the last homework assignment and changed it and then never actually use this anywhere. So yeah, you probably don't need this one. Okay, so that's basically the assignment. Again, it's very similar to what we did in assignment 6, but there are just a few wrinkles, mainly as they relate to the abstract superclass server and then the subclasses file server and web server.